The second part of Chapter 12 deals with what can go wrong in sampling methods. So we're going to look at types of bias. So bias is any systematic failure of a sampling method that overrepresents or underrepresents a portion of the population. The first type of bias we're going to discuss is known as voluntary response bias. This is bias that is introduced to a sample when an individual can choose on their own whether to participate in the sample. So we said that a sampling method is actually known as voluntary response, and that's always bad sampling because what does it introduce? It introduces voluntary response bias. So it can be both a sampling method and a type of bias. Why is it bad? Well, think about it. Those who are more likely to respond to something on their own are typically more passionate about whatever the topic is. If you're asked at the grocery store to reply at the bottom of a receipt to a survey, often those that take the time to do it either had an exceptionally good or maybe an exceptionally bad experience and have a lot to say. So it could either overrepresent or underrepresent the true feelings of the majority of the shoppers. The next type of bias that we're going to talk about is non-response bias. This is bias that's introduced when a large fraction of those sampled fail to respond. This is actually a very large problem with sampling methods. And some people confuse this with voluntary response bias. But in a voluntary response bias, every individual has opted to take part, so there is no non-response. Whereas in non-response, you've selected a sample. But then of those you selected, they just fail to reply. You saw an example of non-response bias in the poll of 1936 done by the Literary Digest. Respondents tended to be Landon supporters, and non-respondents were Roosevelt supporters. Since only 25% of the sampled voters actually completed the mail-in survey, survey results overestimated voter support for Alfred Landon. This illustrates a very common problem when it comes to mailing out surveys. Response rate is often low, making mail surveys vulnerable to non-response bias. I would imagine in this day and age that they would have the same difficulty when it comes to doing things like texting surveys. You're going to deal with a lot of non-response bias. The next type of bias is known as undercoverage. This occurs when some members of the population are less likely to be chosen or cannot be chosen in the sample. Again, this was illustrated in the 1936 poll, which predicted that Alfred Landon would beat Franklin Roosevelt in the presidential election. This survey sample suffered from undercoverage of low-income voters who tended to be Democrats. How did this happen? Well, we saw in the video that the survey relied on a convenience sample where it was drawn from telephone directories and car registration lists. Well, back in 1936, people who owned cars and telephones tended to be wealthier. So undercoverage is often a problem with convenient samples because you are leaving somebody out. And the final type of bias that I'm going to mention is response bias. This is not the same as non-response bias, okay? There is a difference. Response bias is what you do before you send out your sample or your survey. It's a survey or wording in a question that influences the way you respond away from the accurate or truthful response, okay? For example, when I go to the dentist and he's ready to check out my teeth, and at some point he says to me in the cleaning process, "Do you floss every day?" Well, what am I going to say every single time? Absolutely, I floss every day, whether or not that's true or not. Let's look at this first example and see if we can identify how this survey could be biased. It says manufacturers and advertising agencies often use interviews at shopping malls to gather information about consumer habits and the effectiveness of ads. A sample of mall shoppers is fast and cheap. How might this type of survey be biased? Well, even before we answer that, let's see, can you tell me what type of sampling method this is? I would say it's a convenient sample. You just go to the mall because you're bound to have shoppers there. So the type of bias is undercoverage because not everyone shops at the mall, so their opinions would not be heard. The next question is about an Ann Landers column. It says, she once asked the readers of her advice column, if you had to do it all over again, would you have children? She received nearly 10,000 responses, almost 70% saying no. Comment on this type of sampling. I would say that there's a definite bias here, and it would be voluntary response. People who have strong opinions about their children are more likely to respond. Now, sometimes learners tell me that they think this is undercoverage because only her readers have the chance to actually reply. But it kind of depends upon who your population here is. So if it's an Ann Landers column, she's really only caring about her readers, not those who don't read her column. So your population would just be the readers of Ann Landers' column. And the sample would be a voluntary response one with voluntary response bias. Okay, let's go through this example where it goes through all the parts of a survey. So a question posted on the Lycos website on June 18, 2000 asked visitors to the site to say whether they thought that marijuana should be legally available for medicinal purposes. Identify the population, parameter, sampling frame, sample, your sampling method, and you always want to talk about whether randomization was employed, and then any potential sources of bias. So it's helpful for you to know what the Lycos website is. That's just a search engine. I believe it was actually created by Carnegie Mellon. All right, so if we're talking about a search engine that everybody uses, and most likely the population here would be all US adults. And what is the parameter that they're measuring? Okay, so remember your parameter is the numbers that describe the population, which is why I'm calling them parameters and not statistics. I would say that it is the proportion of US adults that feel marijuana should be legalized for medicinal purposes. Now, the sampling frame. So this is your list of everybody from the population from whom you could draw your sample. So it's not specifically stating what our sampling frame is, but it would have to be everyone who has access to the website. Okay, now from all the people who have access to the website, then that's where you're going to actually pull your sample. So my sample would be those who visit the site and choose to respond to the survey. So I think we've kind of indicated what's our sampling method. It's definitely voluntary response. And there is no randomization that I see. So if there's no randomization, you know you're not going to be able to generalize the results to your population. And finally, what's my potential source of bias? It's going to be, again, voluntary response bias. And what am I going to, how am I going to talk about this? So when you do on the AP exam, you should always say, well, how would those who respond possibly differ from your whole population? So I would say that people who chose to respond are most likely more passionate about the issue. And I would say that they're probably likely to respond in favor of legalizing marijuana. So it would lead to an overestimate of the true proportion of the population, which was our parameter we were looking for. Okay, so how would they respond differently? And then is it an overestimate or an underestimate of the parameter? The next example is a textbook question from your sample exercises. It says, examine each of the following for possible bias. If you think a question is biased, indicate how and propose a better question. So if you got a survey and it says, do you think high school students should be required to wear uniforms? Well, I'm looking for any language that's implying that it would go one way or the other. This really just kind of seems to be asking me my opinion. So I would say it's unbiased because it's not influencing my answer. The next question, given humanity's great tradition of exploration, Do you favor continued funding for space exploration? Well, just the language here, given humanity's great tradition of exploration, I think that definitely shows you some response bias, okay, in the wording here. I think it would indicate that people would answer yes, like who's going to go against the great tradition of exploration? So what would be a better way to state this question? Just flat out, do you favor continued funding of space exploration? No leading into it's an amazing thing. All right. Finally, one of the things that we're really shooting for with a good sample would be that it has low bias, okay, so that we're really hitting the mark of the true population. So this example has low bias, and this one has pretty low bias because your bullseye being your mark, okay? And we also want low variability. I'll show you what this looks like in a dot plot, but I think the target kind of illustrates here. So low variability would be like if you're shooting that they're clustered together, close together. So this is low variability, but it totally missed the mark. This one's just bad because low or high variability, look, it's real scattered, also called high variance, and it totally missed the mark. This one has high variability, but at least it's fairly close to the mark. Now, to reduce bias, what we do is we use random sampling. The values from the statistic from an SRS neither consistently under or overrepresent the population's parameter. Now, to reduce variability of a simple random sample, you should use a larger sample size. When we really get into inference, we'll talk about how big is big enough. But of course, the problem is larger sample size, it's more expensive, right? Takes more resources, so just more challenging to do. Here's again an image to show you low variability and low bias. So if you're looking at a sampling distribution, like we did with the jelly blubbers, this is looking great. Here's your true value, low variability, low bias, because it's centered around the true parameter. This one has low variability, but it's missing the mark. This one, high variability, low bias, it's still centered around our true value, okay, but high variability. This one, centered over here now, so it's got high bias, it's missing our mark, and it has high variability. So our goal, of course, is low variability, low bias. So again, if we do a random sampling method, and we increase our sample size, we are going to have the best possible sample to represent our population.